In today's lecture, we are going to see a very important misconception among the students of physics. While studying the physics of ideal gases or perfect gases, you have definitely studied a very important relation between the two molar specific heat capacities of gases, which are denoted by the symbol Cp and Cv. Actually, Cp is the molar specific heat capacity of the gas at constant pressure, and Cv is the molar specific heat capacity of the gas at constant volume. And you have seen that Cp minus Cv is equal to R, where R is the universal gas constant and its value is 8.314 joule mole inverse Kelvin inverse. Okay. So when the students study this relation, they thought that this relation holds always. But here we will see that actually this relation Cp minus Cv equal to R is not strictly followed in many situations. Actually, when you talk about the ideal gas or the perfect gas in normal condition, this relation holds. It means you can say that in case of ideal gas, Cp minus Cv is equal to R in normal condition. Okay. But there are many situations when you will see that this relation will not hold. The reason is obvious. Since this relation is valid or this relation is strictly followed by the monatomic ideal gas under normal condition, so whenever there will be a system which will deviate from the behavior of ideal monatomic gas, then this relation will not hold strictly. Okay, or this relation will be not followed by those systems. In fact, you will see that in case of more complex systems, in case of high pressure environment, and when phase changes take place, or you are talking about the real gases, then the behavior of the system differs significantly from the ideal gas behavior, and that relation Cp minus Cv is not valid in those cases. So let us see, I have mentioned here actually five situations or five types of system when this result is not strictly followed. So the first example is multi-component systems. Actually, for multi-component systems, it is seen that Cp minus Cv equal to R no longer holds. It is not equal to R. When you say multi-component system, it means there in your system there is not only one thing, but this is a combination of several things. For example, you can take gas mixture. When you consider gas mixture, then this relation Cp minus Cv does not hold, or you can say that Cp minus Cv is not equal to R. Okay. Now, the another example where this relation does not hold is the system of real gases. Actually, in case of real gases, particularly near the critical point or liquefaction point, it is seen that this relation Cp minus Cv equal to R does not hold, or you can say that Cp minus Cv is not equal to R, particularly in the region of critical point and liquefaction point. Okay. Actually, what is the reason behind this? I have told you earlier that whenever the behavior of our system will deviate significantly from the monatomic ideal gas behavior, then this result will not hold. So actually, in case of real gases, we cannot neglect the intermolecular forces. Okay, and so since the intermolecular forces are present in case of real gases, and so these gases have non-ideal behavior. Okay, and due to this relation Cp minus Cb equal to R does not hold in this case. Okay. Now, if we consider a gas which is at high pressure, actually when the gas is at high pressure, then the intermolecular separation decreases and intermolecular force becomes very effective. It becomes significant. And when intermolecular force will become significant, then the behavior of the gas will be not like an ideal gas, because in case of monatomic ideal gas, the intermolecular force is negligible. But at high pressure, we cannot neglect the intermolecular force, and so the behavior of the gases at high pressure deviates significantly from the ideal gas law. And in that very case, this relation no longer holds. And so you can say that in this very condition, Cp minus Cb is not equal to R. Okay. Actually, what is the reason behind this? As I have told you that at high pressure, intermolecular force becomes significant, and apart from that, there is compressibility effect also. And due to this compressibility effect and intermolecular interaction, the behavior of the gas is significantly different from the monatomic ideal gas, and so that this relation does not hold. Okay, I think you are getting the things. The fourth most important example for which in which case this relation does not hold is the example of solids and liquids. Actually, in case of solids and liquids, the behavior of the system is very different from the behavior of monatomic ideal gas. Also, in case of polyatomic gases, that is a gas in which molecule there are so many atoms, the behavior of such a gas is also very different from the monatomic ideal gas, and in that case too, this Cp minus Cb is not equal to R. Okay. Now, whenever there is a phase change, that is, there will be a change of phase, in that condition, this relation does not hold good. That is, Cp minus Cb is not equal to R during the phase change. Actually, what happens during the phase change? You can take an example. Let us consider that there is a liquid, and that liquid changes into a gaseous phase or vapor state. Actually, during this transition, or you can take the reversible process too, a gaseous system changes into the liquid state. So when liquid changes into gaseous state, that is called vaporization, and when gas changes into liquid state, that is called liquefaction. Okay. In fact, in these conditions, due to the latent heat of vaporization or latent heat of fusion involved in the phase transition, it is found that Cp minus Cb is not equal to R. Okay. So remember, this Cp minus Cb equal to R, this strictly holds only in case of monatomic ideal gas in normal condition, not at very high pressure and very high or low temperature. Okay. But I have mentioned several examples here. In those cases, this relation does not hold good. So don't think that Cp minus Cb equal to R is a universal relation which will hold always. Okay. So I think now your misconception regarding that Cp minus Cb equal to R holds always has been definitely clear. It does not hold always. Okay. Thank you very much.